Hello guys, welcome to another video in the series of coding. We are going to solve the problem. It's called continuous array. So you are given a binary array nums. You have to return the maximum length of a continuous subarray with equal number of 0 and 1. Let's try to take an example to understand. Now there are a lot of subarrays in this, and the brute force approach to solve this problem is list down all the subarrays, right? And if you list down all the subarrays, how are you going to list down? So let's say you start with this I, then you take this j. This is one subarray. Okay, next time j is here, I remains the same. This is the next subarray. Next time j becomes here, I becomes here. This is the next subarray, and so on, right? So for every I, you can take a j that will start from I plus 1. Okay, so let me write down. So you have two for loops. This is a brute force approach that we are discussing to first of all list down all the subarrays. So you're going to start with the first for loop I से लेके n तक, and the next for loop you will start with j. J ranges from I plus 1 to n, right? So you can list down all the possible subarrays, and it will be O of n square, right? To list down all the subarrays. Now in any subarray, right, whenever you have listed down a subarray, what will you do after listing a subarray? Let's say this is one subarray, this is the starting I, this is the ending j. Now in this you have to see if you have equal number of zeros and ones or not. So the way to do that is, what will you do? Let's think in the brute force way. So we'll keep a count of 0 and we'll keep a count of 1. So I listed down a subarray. Now I will count my 0 and 1. Okay, so first I took two for loops for listing down a subarray. If I am thinking in the brute force approach still, what I will do, I will keep a count 0, I will keep a count 1, and inside the subarray again I will start a for loop, and I will see, whenever I see a 0 I will add a count, whenever I see a 0 again I will change my count, whenever I see a 1 I will add a count, whenever I see a 1 again I will take again a count, and I will check if these two counts are equal or not. If these two counts are equal, then that means that I have a subarray which has equal number of zeros and ones. That means that this is one possible subarray, and now we have to find the maximum length of such subarray. So कोई max variable declare कर देंगे and we will compare with that, right? This is the brute force approach that we can think of. Now let's try to think here, what can we do better? Suppose we have a subarray, right? So instead of keeping a count and traversing again, see, in the subarray somehow we know a 0 is cancelling with a 1, right? So if we see a 0, we need to see a 1, then only the number of zeros and ones will be equal. For every 0 you need a 1 to cancel. Okay, for every 1 you need a 0, for every 0 you need a 1. If you have a 0, if you can cancel with a 1, that means that you have equal number of zeros and ones. Okay, so let's say we give the ones plus 1, okay, and we give a 0 minus 1. Okay, then while traversing itself, see, while traversing itself, let's say I give this 0 minus 1, I give this 1 plus 1, I give this 1 plus 1, I give this 0 minus 1. Okay, now what is happening? Now if I take the sum, minus 1 plus 1 plus 1 minus 1, everything becomes equal to 0. So somehow the sum is finally, becoming equal to 0. So the sum inside the subarray is becoming equal to 0 because I have equal number of zeros and ones, they are cancelling out. So I can give a plus 1 and minus 1 correspondingly, okay, to any of the numbers I want. Take any of them as plus 1, take any of them as minus 1, and if they cancel out, okay, let's take one more example. Let's take this subarray example. Now here will they cancel out? Here they won't cancel out. See, for example, this 0 is minus 1, this is plus 1, this is minus 1, this is minus 1, this is plus 1, this is minus 1. Okay, in this case what is happening? What is the sum? When you are checking the sum, minus 1 plus 1 is 0, but you have minus 1, it becomes minus 1, you have minus 1, it becomes minus 2, you have plus 1 and minus 1, it becomes 0. So finally the sum of this subarray is minus 2. So you don't have equal number of zeros and ones. Okay, but if you had taken some other subarray, right, for example, if you had taken simply this subarray with minus 1 and plus 1, they will become equal to 0. Okay, now what is the logic or approach to solve? So we understood why it's important to take them as plus 1 and minus 1, because they can cancel out and then we can easily check. Okay, now let's see one thing. So what we will do, we will do a dry run and then build up the solution. So let me give here plus 1 and let me give here minus 1 corresponding to a 0. Okay, so whenever I see a 1, I'll give plus 1, whenever I see a 0, I'm giving minus 1, again a 0 minus 1 minus 1, again a 1 plus 1, again a 0 minus 1, again a 1 plus 1, again a 1 plus 1. Okay, now let me see something interesting. Okay, so now see, I have found this. So now let me do one thing. While traversing itself, can I do it in O of n complexity? In one traversal itself, can I do? Now when I have plus 1s and minus 1, now one idea strikes me. See, let me, while traversing, let me just keep a sum of these. Okay, so what do I mean by that? So initially the sum is plus 1. Now plus 1 plus 1, the sum becomes plus 2. That means till now I have 2 1s. Okay, now the sum becomes plus 3. Okay, now the sum becomes plus 2 because I have a minus 1. Now the sum becomes plus 3. Okay, now the sum becomes, okay, wait, now let me observe one thing before going forward. See, in this case what happens is sum has become plus 3 again. I have already seen a plus 3 somewhere. That means what? See, the sum up till this area was plus 3. The sum again up till this area is plus 3. Up till this area it was plus 3. Up till this area again it is plus 3. Means in between that the sum whatever is there is cancelling within itself. 0 and 1 is cancelling because I have the same sum again. I have the same value of the sum again. So that means what? Zeros and ones in between these two boundaries, are cancelling with each other. I have equal number of zeros and ones in between. Okay, I have equal number of zeros and ones. How do I know that? The sum up till this point was plus 3, sum again is plus 3. That means in between, no matter what sum I had, it got cancelled and now I have plus 3 again. Okay, so let's build on this logic. So this is how we can do it in single traversal in O of n complexity itself. Okay, so let's continue and then it will be more clearer. So let me build again. Now we took this sum 1 2 3 4 5 6. Okay, let's build this sum. Now it's plus 4. Okay, here then if I take a minus 1, the sum again becomes plus 3. Okay, now let's note one more thing. Again the sum became plus 3. Up till this point the sum was plus 3, right? Okay, up till this point the sum was plus 3. Up till this point also it was plus 3. Okay, but what happened again? After this point also the sum became plus 3. That means what? That means in between here also it is cancelling. See, up till this point the sum was plus 3. Again here it becomes plus 3. That means in between whatever zeros and ones are there, I have taken plus 1, I have taken minus 1, all those are cancelling, and my sum becomes plus 3 again, which was the same sum here. That means this length, in this length boundary, I have equal number of zeros and ones. See, I have zeros and ones that are cancelling with each other. So again I have one more segment which is having equal number of zeros and ones. Okay, and this is larger than the previous segment that we saw. Okay, so now let's continue. So let's continue further. So plus 3 plus 1 is equal to plus 4, and then again we have plus 3. Okay, then again we have now plus 2, and plus 2 plus 1 is plus 3. 3 minus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4. Okay, this is our entire array. Now whenever sums are repeating, right, for example, consider this case. The sum up till this point is 4. Okay, sum up till this point is 4. Okay, and also what did we observe? Sum up till this point is also 4. Up till this point also sum is 4, right? See, you have 1 2 3 4 5 6 ones and you have 2 zeros. Okay, 6 ones minus 2 zeros is 4 ones. So sum up till this point is plus 4. Again the sum becomes plus 4. That means in this segment also you have equal number of zeros and ones. They are cancelling each other. So whenever you have sum that are repeating, right, whenever a sum is repeating, that means inside that segment you are going to have equal number of zeros and ones. Okay, so now the brute force approach to solve using this method is, so once you have created this, right, while traversing you can create this in O of n, right, but you also need to store that you had seen a plus 4 before, then only you can check. Now again if you see a plus 4, you also need to check when did you see a plus 4 last time. Okay, because see, here also you saw a plus 4, here also you saw a plus 4 at this boundary. Now this segment is better, right? This segment this segment is better. This segment is better than this segment, right? So see the light blue and the dark blue segments. The light blue segment is having a more length than a dark blue segment, right? So this segment is giving me a better length. Why is it giving me a better length? Because I saw a +4 before here compared to the +4 that I am seeing here. So I should keep the +4 that I am seeing on earliest, right? On the best case, I will get a maximum length of the segment only when I use the +4 that I saw previously, which was the best left possible, the leftmost possible +4. I should use that. So I should store this +4 in the least index on which I saw the +4, right? If I had stored this index and I know I am seeing a +4 again, I know that in this entire segment I am able to get a better length. Okay, so now let's use a map data structure. That's why we need to store the index of a +4 that we saw already, and then in just O of n traversal time and O of n space, I can just solve this problem. Okay, now let's solve this problem again. So what I'm going to do, let me just erase this. So I'm traversing this is fine now, but also while traversing I am also going to store it in a map so that I can keep a note. Okay, I can keep a note of the values that I see. So first in the map, what I will do, I am seeing a +1, right? So I will store a +1, and I know that I am seeing a +1 at the 0th index, so I will store that in the map. Okay, next I see a +2, so I will store +2 at the first index. Next I see a +3, so I will store a +3 at the second index. Okay, now next I am seeing a +2, but I already have a +2. That means what? That means this segment is going to give me a sub-array which is having equal number of zeros and ones, right? Because I had seen a +2 here, now again I see a +2 here. That means this segment is going to give me a sub-array with equal number of zeros and ones. So I will see from the map itself. I will see at the first index I had a +2. Again at this index, right? Again at the third index I am having a +2. Okay, let's note this carefully. So let me do one thing, let me just erase this for once. See now I am iterating over, and at the third index I see that my sum is +2. From the map I see at the first index my sum was +2. That means what? 3 minus 1 is equal to 2, right? I have a subarray of length 2 which is going to give me equal number of zeros and ones. So my answer is 2 as of now. I have a best case subarray of length 2. Okay, best case subarray of length 2. So let me store 2 in the answer, and let's go forward to next iteration. So as of now in my answer I have a subarray of length 2. Okay, now let's go forward. Now what is the next case? Next case I am iterating, I get a +3. Okay, now let me check if I have a +3 already. I have a +3. From the map I know that I have a +3, right? From the map I know that I have a +3, and it was occurring at the second index, and the index that I am iterating over now is the fourth index. That means again I have a subarray of length 4 minus 2 of length 2. Okay, it is of the same length as my answer, so I will just go forward. Okay, now let me go forward. So let me just erase this and let's go forward. Now I see +4, right? So +4 is not there in the map, so I will store it in the map. And it is at which index? I will store the index number 5. Okay, now let's go to the next case. Next I see a +3 again. Okay, next I see a +3. So I will check in the map, when did I see a 3? I saw a 3 at the second index. Again I am seeing a 3 at the sixth index. So 6 minus 2 is equal to 4. I have a subarray of length 4. Okay, this is the subarray of length 4. Okay, this is the subarray of length 4, which is cancelling out because they have equal number of zeros and ones. At the sixth index, while iterating, I found that I have a +3. At the second index, from the map I found out at the second index I already had a +3. That means what? That means in between the sum is 0. That means my zeros and ones are cancelling each other. So I have a subarray of length 4 currently. Now this is better than my answer, right? So I will change my answer and make my answer equal to 4. my answer will become equal to 4. Now let me go forward. Now I am at the 7th index. At the 7th index I am seeing a plus 4. I already have a plus 4 at the 5th index. That means 7 minus 5, 2. I have a subarray of length 2. It is not better than my answer, so I will just go forward. Okay. Now I am at the 8th index. I see a plus 3. I already had a plus 3 at the 2nd index, right? So I will check 8 minus 2. 8 minus 2 is equal to 6. 8 is my current index. 2 is the index from the map, which is the leftmost index at which I saw 3. Okay, leftmost index at which I saw 3. This is the leftmost index at which I saw 3. This index, right? This is the leftmost index at which I saw 3 at this index. And now at my current index which is 8th, right? 3, 4, 5, 6, 7, 8. Again I am seeing a plus 3. That means in between my zeros and ones are cancelling out with each other. I have a subarray of length 6, which is better than my current answer. So I will change my current answer, and my current answer will become equal to 6. Okay. Now let me go forward. Next I have a plus 2, and in my map I had a 2 at the first index. Okay. So 9 minus 1 is 8. I have a subarray of length 8, which is giving me a better answer. So I will change my answer, and my answer will become equal to 8. Okay. Now let's go forward. So now let's go to the 10th index. At the 10th index I have a plus 3. At the 10th index I have a plus 3. In the map I have a plus 3 at the 2nd index. Okay, so 10 minus 2 is again equal to 8, which is same as my answer, so I will not change my answer. I can just go forward. At the 11th index again I have a plus 2. In the map I have a plus 2 at the first index. So 11 minus 1 is equal to 10. 10 is better answer. So I will change my answer, and my answer will become equal to, let me just delete this. So my answer will become equal to 10. Okay, my answer will become equal to 10. So I will change my answer, and the best case answer that I have is 10. Okay. Now let me go forward to the 12th index. At the 12th index I again have a plus 3. I have a plus 3 from the map at the 2nd index. So my answer is again 10, which is already my answer. So I will just go to the 13th index. 13th index I have a plus 4, and I have a plus 4 at the 5th index. So 13 minus 5 is equal to 8. So this is not giving me a better answer. So my answer is 10. I have a subarray of length 10. Okay, and how did I get that subarray? I got that subarray from here or here. Okay, you can take any of the answer. For example, at the 11th index and the first index. Okay, so let's see that. So this is the first index. So after the first index, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th. So this is a subarray of length 10 that is going to have equal number of zeros and ones. So you can see that zeros and ones are cancelling out all amongst each other. Okay, now let's go forward to coding it. So how to code this? So we are giving a plus 1. Okay, we are giving a plus 1 whenever we see a 1, and we are giving a minus 1 whenever we see a 0. Okay, so let's see. So for int I equal to 0, I less than nums dot size, I plus plus. What am I doing? So whenever I see a 1, I am giving a plus 1. So let me take a variable sum that will keep track of this. So whenever I see a, let's say nums of I is equal to 1, right? In that case, what I am going to do? In that case, I am going to add 1 to sum. In that case, to my sum, I will add 1. Okay. Otherwise, I will add minus 1. So whenever I see a 0, I am going to add minus 1. Okay. So now this is it. Now I also need to keep a map. I have to see if I have ever seen a sum before. So unordered map int comma int m. So first map will store the value of the sum. First a key in the map will store the value of the sum. Okay, and the value in the map, right? The second part of the key value pair. In the key value pair, the key will be the sum, and the value, right? Value will be the index at which that particular sum occurred in the leftmost place, because we want to find the maximum segment length, right? So we will take the leftmost place. So let's see that. So first I will check if it is occurred in my map or not. So auto id is equal to m dot find sum. Okay, so if sum has already occurred in the map, so if sum not equal to m dot end, that means sum is already there in the map. In that case, what I should do, I should just compare it with answer. So let me give an answer variable. Okay, and now I will just compare it with answer. So answer is equal to max of answer, comma, I is the current index and the second value in the map, right? I mean in the key value pair, the value is going to give me the leftmost index and I is the current index. So this will give me the length of the segment in which zeros and ones are cancelling out with each other. Okay, so that's it. This is the simple logic. Else we will just insert it in map. So else m dot insert, we are going to insert the sum along with its index. That's it. Very simple code. This is the entire code, and after this you can just return answer. Okay, now there's one more thing in this which I forgot to add. Can you point it out? What is, okay, if sum, so here I should give it. So first let's see this, and then there is one more thing that, yes, so this is the case which I was going to talk about. So this is very important for all the, why is it failing for this test case? Because, okay, let's see why is it failing for this test case. So we have a test case 0 1, right? So what is happening, I am giving -1 here and I am giving +1 for 1, right? So in this case, what is happening? So initially the sum is -1 and then the sum becomes 0. So in the map you put -1, okay, which is occurring at index number 0, and you put 0 which is occurring at index number 1. That's it. You don't have any solution at all because sum is never repeating, but in the zeros and ones are cancelling out. So how can we find a solution in this case? See, you have to observe that 0 is the sum you should keep in the map already, because see, the sum is becoming 0 here. That means you can consider a 0 that is there at the -1th index. So if in the map you store a 0 that is occurring at the -1th index, right, that means the sum was initially or originally 0. Okay, sum was initially or originally 0, and then you gave a +1 and you gave a -1 and the sum cancelled and became 0 again. So in the map there is a small trick that in the map you give that there was already a 0 at the -1st index. At the -1st index there was a 0, and the advantage of that is what? Now when you are traversing over, right, when you are traversing over these values, when you come to the first index, you will observe that there is already a 0 at the -1st index. So the length of the segment is 1 minus -1. So there is a length of segment of length 2, which is your answer. So for these cases you also need to give a 0 at the -1st index. Okay. So that is also very important. So m dot insert 0, consider it at the -1st index. Okay, that's it. Now let's submit and see it should work. Okay, I should give a bracket. Let's submit again and see it should work. That's it. Thank you.